Hi guys, my name is Miguel and I will be teaching you guys how to draw a Lewis dot structure that is for xenon O2F2. Now first of all, we will have to calculate the number of electrons in the molecule. We'll be using our periodic table and its respective groups to do so. Now we know that xenon has a full octet because it's a noble gas, and that is 8 electrons. We'll say 8 electrons plus 2 oxygens because of their subscript. 2 electron has 6 valence shells. So does fluorine, and there's also a fluorine does not have 6. It has 7. And so we have a total of 34 electrons. Now we can start our Lewis dot structure. Let's make xenon the central atom. We have 4 atoms, which are oxygen and fluorine. Therefore, let's do 4 bonds. Each bond consists of 2 electrons. So, oxygens, fluorine, and we have 34 electrons. So we already have 8 electrons. Now let's count the rest, putting them around the remaining electrons that don't have their full octet. That is, see, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, and we have 2 remaining electrons which will be given to xenon, and we call those lone pair. Doesn't explain the impact that a lone pair has, its repulsion. That is the reason why a VSEPR is very important to understand the geometry of the molecule. Now I will be drawing out the VSEPR diagram. Okay, so to do so, we will take into consideration the number of bonds and will include the lone pair. Now that's 1, 2, 3, 4, 5. The number of electron bonds are used to determine what category the molecule falls under. Now in this case, when there's 5 bonds, it is considered trigonal bipyramidal. Which has a generic shape of this, where you put these round dots indicate the atoms. However, because we have a lone pair, it will be drawn differently, and it's considered a seesaw. Seesaw. Now once again, we'll make xenon the central atom. We'll draw out the bonds of oxygen along with the bonds of fluorine. Now this time we'll draw wedges to show the 3-dimensional geometry of the bonds. For example, we'll draw out this one right here. Since it's being projected outward, we will draw a dashed wedge. That's fluorine. And now we'll draw this one right here, which is coming forward. And we'll draw a wedge like this one to indicate its 3D shape being pointed out. Sorry, that's like a very horrible drawing of that. Let's see. There it is. And we'll place the two lone pairs and the rest of the electrons. Now, because of these lone pairs here, its repulsion is greater than the bonding pairs. So lone pair to bonding pair is greater than bonding pair to bonding pair. Therefore, these angles here will be less than their original trigonal bipyramidal shape, which in this case, this one here has a equatorial degree of less than 120, and that's equatorial. This one here has a degree of less than 90, and that's axial. And just to let you know, this one right here would be greater than 180. And that is how you draw a Lewis dot structure in VSEPR. Thank you.